Hey, hello everybody to a quick tip here on the Embergen to Houdini connection. So I was wondering how I can bring my assets from Embergen into Houdini to do further work and progressing there with the scene setup. And I want to share the technique I found to you guys. So first of all, make sure you have your effect set up in Embergen. For our case, we take this battleship muzzle flash here. And we gonna adjust the parameters accordingly to your task. So we gonna take this preset here straight away. Will be done in Embergen directly with the export node. So first of all, we should make sure we understand pretty much what an OpenVDB actually is. And on the openvdb.org page, you have a lot of information about this database and how it's processing volumetric data inside the different software solutions. So you see here that a lot of visual effects software is able to export, import, and to handle VDB data. And this is the same we will now use as an approach in the Embergen export setting. So first of all, before you start exporting any of your VDB, please make sure you know what kind of channels you need for the further approach inside of Houdini. What kind of channels I'm talking about. Let's have a look here at the export node for the VDB. And mostly you pipe this into your volume processing node. So pick the VDB and input of your export node. And you can see here that we have here different channels which are stored inside of the volume database, the VDB. So this is density. This is mostly, as you can see, the smoke density. Everything that is created when smoke is creation. So everything related to smoke is mostly connected to a density field, because you can change how dense the smoke here should become later. And you can specify density mostly in the way the smoke is looking, like dense or thick or very large density, like plumes or volcano plumes. Those are elements that have a very high density, so keep this in mind. And also when you only export a chimney plume for any related shot, you actually only maybe need only density and no other channels at all. So for the temperature, this is pretty much what makes the smoke rise and what also makes our simulation getting dynamic in terms of the fluid behavior. Because as you might know, different systems, they have different temperatures, from a candle which has a very low temperature compared to a gasoline explosion, which has for a short amount of time a very high temperature. And this is going upwards to different elements like you have in heavy explosions, or like, for example, when you have to simulate a atomic bomb or something like that. There you have temperatures that are mostly in an extreme high value. So we also want temperature channel here to get exported also. The fuel is mostly this, what keeps our flames burning. Like when you have fuel inside a system, then they are mostly able to make flames rise and let flames live. We also want flames, which we can see here in our export. And we want also the whole velocity. Everything you see here is pushing through the space, like, so velocity defines all those turbulent and swirling, which you can also address and adjust in Embergen. Okay, when all those fields are set, make sure that your fields have an corresponding name, like temperature name is temperature, fuel is fuel, density is density. And for this purpose, you can also set the VDB grid class here to a level set or fog volume, but we leave it to unknown because this is where I got the best experiences with. And now you set your directory here. You can see that Here is one explanation of one frame from the VDB. And before exporting, make sure you have enough space available for all the fields which are stored in the single VDB. So now let's set the directory and let's export this. So the export is in progress, depending on your machine setting and also depending on the channels you store inside the single VDB. So we are now in Houdini, and you can see that I reference the different channels, and you can see that we get a result similar to the one from Embergen. And we're gonna achieve this by addressing the different channels. So let's have a look at this. As I mentioned before, everything is stored in channels like temperature, density, and the velocity and flames field. What you have to do is putting your VDB inside of your Houdini with a file node, and everything looks pretty much like this. Not so cool and not so fancy. So I put down transform node here. We convert everything again into a VDB space with precision of 32 bits, float, and we're gonna then can address every single channel, which you can see here. Density, temperature, flames, velocity, which make then can be made visible with a blast node. So here I referenced the density channel, and as I mentioned before, it's pretty much only the smoke that is generated here and stored in the VDB. You can also have a look at the temperature field by referencing the temperature. You can see how this is pushing the smoke in different directions. And to make it visible, we need to do a pyrobake volume. In the pyrobake volume, we can then change the bindings of our creation, the smoke volume and the diffuse volume, for example, to the density field. Make sure you look inside of your field here. We have here the density one with the accordingly channels. We use the color field CD, color attribute, for the diffuse volume, and when this is entered correct into the binding, we can then address the smoke field density, as you can see here. Same goes for temperature and for the scattering, fire, secondary fire, and as you can see, we have the flames for the fire, the temperature for the color. So this means that source volume, temperature. So here I bake the scatter with temperature, density field, scatter field, and the fire with flames and temperature. So accordingly to those settings here, scatter and fire, you can use it here above in the settings field. You can see you can shade your cannon fire here accordingly to the different channels provided. You not only can change the look very much to your needs, but also make it looking more different or whatever you need. And we then can reference this with a null to a lob network, which means that we can use Karma for the shading purpose. The shading pretty much happens with the XPU Pyro Preview shader. We don't need the Pyro shader when we want to use XPU. Let's have a look here. So make sure that you go into your pyrobake volume and that you do in the material here, in the assign material, you need to use the Karma Pyro Preview to make this working accordingly. So we have the Pyro Preview one here, and we need it also here. So to address this, let's delete this Pyro shader, type tab and then XP for the XPU Pyro Preview, and make sure that you assign it also here in the Assign Material tab by hitting this little tin here, the spike, and then drag it over there. So now let's go into the LobNet and let's see how it looks. Here in the LobNet I just imported the scene all to make it an USD, then assigned the material. But here is the plume material, which is the Karma Preview 1 I just mentioned before. We then assign it with an assign node, and we can see here that we have here the plume. So accordingly to those settings, you can get the result you see here. This is rendered in XPU in Karma. We can switch the VDB here, and we can see that we get a result we then can change here in the different results. So you definitely should play with the settings to get the desired result, but I think you get the idea of how you can put your Embergen simulations into Houdini with the adjusted channels like density, temperature, velocity and flames. And I hope you enjoyed learning something new here, and it may help you in your future projects. Thanks for watching. Have a great day. See you soon. Bye.